Hey guys, Mr. Milton here. Today we're going to talk about solving quadratics using square roots. At the end of this video, you should be able to determine when it is appropriate to use square roots to solve quadratics and when it's not. And you should be able to solve a quadratic equation using square roots. Okay, at the end of last lesson, I explained why solving quadratics by graphing isn't always ideal. Today we're going to look at the second of 5 methods for solving a quadratic, and this method is the fastest, but can only be used in certain situations. So first, let's look at solving a quadratic by graphing. So we have 3x squared minus 3 equals 0. Remember, to solve by graphing, we had a 5-step process. First, we're going to find the axis of symmetry. That's opposite b over 2a. In this case, b is 0 because there is no value that's by just x. So our axis of symmetry will be at x equals 0. From there, we'll find our vertex. We'll do that by plugging in our x into the function. So 3, 0 squared minus 3. And so that gives us 0 minus 3, or negative 3. So our vertex will be at 0, negative 3. 1, 2, 3 here. We will make our table. Okay, remember our table will have 0, negative 3 in the middle. We'll pick some other values, 1 and 2. Plug those in. 1 squared times 3 is 3, minus 3 is 0. 2 squared is 4, times 3 is 12. 12 minus 3 is 9. Okay, so 1, 0, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up here. Okay, going this way, all the way up here. These points aren't super important because we're just solving. But it does tell us where our graph is going. Okay, all right. So our solutions, if you remember, are where our graph crosses the x-axis here at x equals 1, and on the other side x equals negative 1. These are our solutions. Okay, so that is, I guess if I said 5-step process, our 4th step was graphing, and our 5th step was identifying the solutions. Okay, so now we'll show you how to get to the answers, but in a much quicker way. First, let's get 3x squared by itself. Okay, so we're going to solve this algebraically. I'll add 3 to both sides. And so now we have 3x squared equals 3. Okay, how do we get the x squared by itself? Sorry, we'll divide by 3. I guess we should get x squared by itself. Okay, divide by 3, we get x squared equals 1. So in order to get the x squared by itself, we need to square root both sides. Okay, when doing that, we should get x equals 1. So how do we get the other answer? We can take the square root of both of these. The other root. Okay, when you take the square root of x squared, you're asking yourself, what number times itself equals 1? Okay, we know that 1 times 1 equals 1, but doesn't negative 1 times negative 1 also equal 1? So we need to include both numbers that work. So we don't just say 1, we'll say plus and minus 1. Flip on both sides. Okay, so this is a recurring theme in this unit. When you take the square root of something, you have to remember both the positive and the negative root. you have to remember both the positive and the negative root. So let's look at some more problems here. So we have 2x squared minus 98. Let's just solve these. Okay, we're getting the x by itself. So 2x squared equals 98. Divide by 2. X equals 49. Sorry, x squared equals 49. Okay. From there, we'll take the square root. Remember that when we take that square root, everybody, hopefully, will say, hey, 7. But 7 times 7 is 49. Also, negative 7 times negative 7 is 49. So, plus or minus 7. Number 2, subtract 4 from both sides. 3x squared equals 27. Divide by 3. X squared equals 9. And so from there we have to take the square root, both sides. Get x equals 3 or negative 3. So you could write it like this, as long as you don't put the parentheses around it to make it seem like a coordinate. But most of the time you'll see it written as plus or minus 3. Okay. You can pause these, try to see if you can do them on your own. If you did that for this side, our next step would be subtracting 32. Take the square root, or sorry, divide that by 2. We get x squared equals negative 16. Okay. Here, you see that x squared is a negative number. There is no real number that you can multiply by itself to give you a negative number. So if you run into this, we will not take the square root. It doesn't work out for us. And so this is an example of a problem with no solution. Okay, we saw that when we were graphing as well. All right, then number 4, we have 4x squared plus 25 equals 25. We will subtract 25 from both sides. Get 4x squared equals 0. Divide by 4. X squared equals 0. Take the square root. And the square root of 0 is 0. Please do not write plus or minus 0. 0 is neither positive or negative. 0 is the only solution. Okay? Alright, what would happen if I were to graph each of these instead of using square roots? Alright, so let's look at this. The parabola would, all of these have positive a, so they all open up, but we'll say intersect the x-axis at 7 and negative 7. Okay, this would intersect the x-axis at 3 and negative 3. Number 3 would not intersect the x-axis. That's why there's no solution. And number 4, it would intersect only at 0. And these are all the x values that it works. So this is in here just to remind you that these different forms, whether we solve by taking the square roots, or whether we solve by graphing, or whether we solve by any of the other methods that we're going to talk about in this unit, these are the same things, okay? It's different ways to display and find the same answers and solve the same questions. All right. So, looking at the next problem, we're going to solve these quadratics using square roots, and we're not going to use decimals. Now, what happens is when we start solving equations, people will get a calculator out and they turn their brain off. Please don't do that. We just got out of the radical chapter, so we should be able to handle these pretty well. So we have 9x squared minus 64 equals 0. Let's solve. Okay, going through the same way, trying to get our x by itself. Get x squared equals 64 over 9. Now, a lot of people run to make this a decimal. Don't. Okay, we need to take the square root of this. Because 64, 9 does not go into 64 evenly, it will be easier for us to keep this as a fraction. Okay, and the nice part about this is, when we take the square root of this, there's a perfect square in the denominator. And so, the square root of 64 over 9, remember, is the same as radical 64 over radical 9, which is 8 over 3. Now remember that we want to take both the positive and the negative root. Okay, so we won't just say 8 over 3, it's plus or minus 8 over 3. Okay, number 2. Again, we're trying to get that x by itself, so I'm going to add 8 first. 1/3 x squared equals 28. To get x all the way by itself, I need to multiply both sides by 3. And that gives me x squared equals 84. Then I take the square root. Again, not writing our answer as a decimal. That means I will have to simplify radicals, as we've been doing. Excuse me. Okay, so that will be 16 times, let's see, 4. There we go. 4 times 21. That works out. 7 times 3. 2 and 2. Okay, so 2 radical 21. Again, that is the positive root. I need to make sure I take into account the negative root, so it would be also the negative 2 radical 21. Alright, so here are our answers without using decimals, allowing us to use our skills with radicals. Alright. So, look, I've talked about, or we've solved using square roots for this whole time. What did we notice about all these problems? Okay, remember at the beginning I said that certain things have to be true in order to use square roots. Why would it not work for this function? Okay, if we just said, oh, we're going to move 16 to both sides, x squared equals 16. In order to use the square roots, the b value must equal 0. Okay, and so we'll have to look at different ways to solve quadratics when b is not 0. Alright, so kind of necessitates a new way. Alright, practice this. I'll see you tomorrow.